We are doing homogeneous higher-order differential equations, part 3. So we are doing more test and exam type questions. I'm not going to do the theory though to save some time, but as we continue, I will mention important theory that we have done in video 1 and video 2. In the first question, they ask us to find the homogeneous linear differential equation with constant coefficients. Remember, in your course, we're only doing constant coefficients whose general solution is given. So what did they give us? They've given us the general solution. We must find the homogeneous differential equation with constant coefficients. So let's recap again. Since they've given us that, we know it will be E equal to C1e to the 0x plus C2e to the 2x. A common mistake students make, because there's just C1, they forget that they have to times by the factor e to the 0x, which is just the 1. So from our previous videos, we know now that since we have our general solution in this form, it means that we are going to get two distinct real solutions, because M1 and M2 are distinct real values, M1 and M2 distinct. So what do we know from there now? That if we have M is 0 and we have that M is 2, we know from first year that if we have two factors equal to 0, that we will times them together, and that will give us our characteristic equation, which is m squared minus 2m. Our characteristic equation equal to 0. Just to recap from the previous two videos, m is the first derivative, m squared the second derivative. Hence, if I just have y, there's no derivative, so it is the constant times n to the 0. It will just be a constant. Very important. Recall from the first video that the highest power of m will be equal to the highest power of the homogeneous differential equation, and I end off with what they've asked me. I see that my homogeneous differential equation will be a second order differential equation. Let's go to the next example. We see here now that they've given us the general solution, but recall from our previous two videos, if we have two complex roots in conjugate pairs, alpha plus beta I, we will always use the positive beta I. This is more convenient to do it, and then our complex roots will be e to the alpha x. Remember, your alpha there will be the power of x. Your beta here will be the coefficient of x. So they've given us now in the reverse order. What do we see here immediately? We see that our alpha is negative 1. What do we see? Coefficient of x is beta. Our beta is 1. So we have minus 1 plus I, and we have the conjugate minus 1 minus I. So they will always be in conjugate pairs here. So now we do the following again. Since m is minus 1 plus I and m is negative 1 minus I, we take it across, we get our two equations, we times them together. Now, very important what I do here, I create my own bracket here. I create my own bracket around the equal terms. So I have m plus I minus I, m plus I plus I. Very important there. What you can do then, you see immediately it's difference of two squares. So we have m plus 1 squared and we have minus I squared. Minus I squared is 1. The other method that we can use that I always mention in my videos, I've noticed that students often forget about it. If we times to a complex number times its conjugate, we can just square the alpha and we can square the beta, and that will give us our final answer. So what I could have done here as well, I see that I have m plus 1, so I square it, and I see the coefficient of I is 1, so I just go plus 1 squared. And if I times that out, I will get the same characteristic equation. My same characteristic equation. Now, very important, as you know now from everything we've done, m squared is the second derivative. M is the first derivative. But since I have 2 times 1, that means there is no derivative. It is actually 2 times m is 0. That is why I need the y there. So that is my final answer. D squared y over dx squared plus 2 dy dx plus 2y. So often students forget about that y. That is a common mistake. Let's go to the third example. We're going to the third example. They give us, so now it is a bit longer, the general solution. They give us this general solution. Y is C1 cos x plus C2 sin x plus C3 cos 2x sin 4, C4 sin 2x. Why did I do the grouping in green and blue? Because just note, here I have the same angle, hence the green grouping. Here I have the same angles, hence the blue grouping. So what we will do first, we will first of all do y1, the green part. We see immediately that we have our complex roots. Our complex roots will always be in the form, e to the alpha x, c1 cos beta x, c2 sin beta x. So what do I know immediately from what is given? I immediately see I need to get alpha plus beta I. I see my alpha is 0 and I see my beta is 1. So the beta must always be the same. And a common mistake students make, they forget to immediately write down the conjugate. Please do not make that same mistake. So since the roots are in conjugate pairs, we have m is I and m is negative I. So we take them across, we have our 2 factors, we times it in. So you can see here, I've mentioned this again, very important. It is the factor times by its conjugate, so we can just go m squared times the coefficient of I squared, we get m squared plus 1, and that is our characteristic equation for our green part, y1. Now, let's do y2 quickly. y2 is the blue part given. So what do I see immediately? I see immediately it's also going to be complex roots. Very important, my complex roots. My complex roots will be in the form alpha plus beta I. What do I see? My alpha is 0. Alpha is always the coefficient of the power of the coefficient of x in the power of e. So I have 0 plus my beta is the coefficient of x. They must be the same, so I have 2i. So don't forget to write down the conjugate, minus 2i. So when I take it across, I have m minus 2im plus 2I. Now, this is also a common mistake students make. They forget to actually times the two brackets together. So again, our usual that we are seeing often, so we just get m squared plus 2 squared, m squared plus 4. That is our characteristic equation for my y2, for my blue part. So I have two characteristic equations. What was my first one? My green one was m squared plus 1. Just recall, my first one was m squared plus 1, and my second one was m squared plus 4. I times them together, just normal school maths, I FOIL them, I end up getting the solution. So what is my equivalent homogeneous differential equation? From my characteristic equation, I have the fourth derivative, since it's equivalent to the highest power of m, so fourth derivative plus 5, second derivative plus 4, 1 is always y. Do not forget the common mistake from students that we need to put the y in. So we are on our third and last example. Let's go through it together quickly. So they will, in this case, now give us the general, the differential equation, third order differential equation. They just give us one solution. So remember what's going to happen here, because it is a cubic differential equation. Our differential equation will be in this form: plus c2y2 plus c3y3. I hope you remember that from our previous videos. But now, this is a different type of question. They've just given us one solution. So let's recap. We are just given one solution, e to the negative 4x cos x. So we know we're going to have complex roots if they give us, or if it's given that e to the negative 4x cos x is a solution. So that actually means that our alpha is negative 4 and our beta is 1. Alpha negative 4, beta is 1. So we're going to have our factor minus 4 plus I. But remember, our roots will be in conjugate pairs. So we will also have minus 4 minus I. The next step, I took them across is 0, n plus 4 plus I is 0. That's my next step. And then I'm going to times the two brackets together. So what I've done now earlier, you are familiar with that. Now I create my own brackets around the m plus 4 so that I have a factor and its conjugate, so that I can immediately just do m plus 4 squared plus 1. So here I've just shown where it came from, but remember, you can just immediately do that, and when you times it out, you will get this answer. But now, just to recap, just focus here. Just remember our factor is n squared plus 8n plus 17. What I'm going to do, I'm going to find my other factors, because remember, I have the cubic characteristic equation from here. But now I only got a factor squared. I need another factor. Since it's m squared, I won't use synthetic division, I will use long division. Now, I'm not going to go over long division. I mean, nowadays the kids do it in primary school. Not to waste time, I'm not going to go over that. You can make sure when you do the video, just pause here and make sure you understand it. So here I got an extra factor. I had 8m squared plus 8m plus 17. Now I also have m minus 2. But now we know that we had this part which we already said was this part. Since why? Since my alpha was -4 and my beta was 1. So I need to replace that. That should read as -4x. Why? Remember that was given. And then we have the plus c3 sine x. Why? Because if I go back, my alpha was -4. My alpha was -4 and my beta was 1. So there I have that factor. Now I just need the -2, the 2. So let's maybe just take this one out. So what we need to get y is c1e to the 2x. Since that is my only factor here. Here I had my complex roots. My alpha was equal to -4 and my beta was equal to 1. And there I have my final solution. So I hope you understand that one. Now here I have post some practice exercises. So 5 questions. Please make sure you do it and you familiarize yourself with it. I will post the solutions in a special video on all the practice exercises. In the next video, we will start with our non-homogeneous differential equations, which we're going to solve using the undetermined coefficients. And this is the end of the homogeneous differential equation playlist.